See, now next part we have to see it here. This part is related same with the reflections. Already we studied about the mirror. Now we have to study about the lens. Lens is transparent object. It's a transparent. Basically, it's going to be divided in two types, but further we can divide into the multiple types. First one, we can say that it is the convex lens. Second one, it is the concave lens. Third one is known as the plano concave. And fourth one is known as the plano convex. Actually, this convex lens is known as the biconvex, biconcave. But we are going to be write down the convex and the concave, but actually we are going to be write down the biconcave convex, cause its both side are convex. It's biconcave. Let's see here if we consider So this is called as the biconvex. This is called as the biconcave. From one side plane, and this is called as the plano concave, and one side plane, and this is called as the plano convex. So in this manner, there is a different types of lenses we are going to be used, and very interesting. Convex mirror is known as the diverging mirror, while the convex lens is known as the converging lens. It is known as the converging lens. So something we can judge in case of the convex, somewhat rays are concentrate on a particular point, while this concave lens, it is known as the diverging lens. It is called as the diverging lens. So let's start with the first one, converging lens and the diverging lens. So it's very interesting. In routine life we use lens in our specs. They have a different power. Power is nothing, it's going to be depend on the focal length. It's our next part, we will see. See, if I consider I have this convex lens, this is my principal axis. Here, this is pole, and here we are going to consider the f1. Guys, always keep in your mind, in case of the lens, there is a two focal length will be there. One is called as the f1, one is called as the f2. So here, first one is the f1, here this is f2, and instead of the center of curvature, because here the center of curvature is not a suitable word. So rather than center of curvature, here we are going to be do it 2f1 means the double of f1, here double of f2. So we can use the f1 here 2f1, f2 here 2f2. Got it? Suppose if parallel rays are incident like this, so in case of convex lens, see, already we discussed that parallel rays indicate that object at infinity. Always keep in your mind, when parallel rays will given, then you have to understand that object at a infinitive distance. So definitely your image will going to be formed on focus. So it's going to be, see here, all rays are concentrate and form the image So this phenomena is known as the converging. This is known as the converging. And due to this reason, this lens is known as the converging lens. This lens is known as the converging lens. So anybody is going to be asked why the convex lens is going to be considered as a converging lens, then definitely all rays are going to be converged, concentrate on a particular point on principal axis. That's why it's going to be considered as the converging lens. Similarly, if we talk about the concave lens, then concave lens, then like this. Here, this parallel rays like this, like this, like this, like this. The rays is like this. It's going to be diverse. The rays will diverse. But once we take a extrapolation of all rays, then the extrapolation of all rays is on focus. The extrapolation of all rays is on focus. So this extrapolation from the image, and this phenomena is going to be called as the diverging of rays. That's why this lens is known as the diverging lens. Diverging lens. Got it? So in this way, there is a two different types of the lens will be there. What we have to study, one is the concave lens and one is the convex lens. Similarly, already we studied the ray diagrams in a mirror. Similarly, ray diagrams we have to draw in case of the lenses. But students, you have to practice a lens ray diagram with the help of the pencil and scale. If anybody have a doubt during the ray diagrams, then you can ask me. Okay, fine. So this is about the concave lens and the convex lens. Here, for numerical purpose, they give a formula. It is known as the lens maker formula. Lens maker formula. In 12th standard, there is a detailed derivations of the lens maker formula is given, and this also known as the thin lens formula. Actually, there is the small difference will be there, but for your understanding, we just going to write down the thin lens formula. In thin lens formula, we have to take some of the exceptions, then only we can say that it is the thin lens formula. So it's going to be given like 1 upon f is equal to 1 upon v minus 1 upon u. C, keep in your mind, in case of the mirror equation, 1 upon f is equal to 1 upon v plus 1 upon u, while at here 1 upon v minus 1 upon u will be there. And same thing for magnification, we can say that hi upon ho, but here v upon u, not a minus sign. See, in case of the mirror, minus v upon minus u, but here it's a v upon u. This is called as the image distance upon object distance is equal to height of image upon height of object is equal to magnification. Most important part. Got it? Okay. In next session, we just go through the numericals and we are trying to understand how to solve the numericals based on mirror and the lens.